Good morning or good afternoon. It's going to be one of those days, but welcome to our latest installment of our Tobii Pro Lab series, Get to Know Tobii Pro Lab. Today we're discussing screen-based eye tracking using the Flanker task. We've also hosted other tutorials like this in the past, including using Tobii Pro Lab with our wearable Glasses 3 recordings. The recording for that tutorial and other awesome webinars can be found on our Tobii Resource Center. Okay, but for now we're going to move on to today's agenda. Okay, so today's webinar is designed to give you a brief overview into the capabilities of Tobii Pro Lab. We hope it inspires you to consider how you might employ eye tracking in your own research studies. We'll discuss how we set up this task and spend most of the time going over the analysis tools. Tobii Pro Lab supports your entire research workflow from start to finish, including study design, calibration, recording, qualitative and quantitative analysis without other tools needed. Tobii Pro Lab is flexible to a variety of testing situations. It's compatible with all of our hardware in our portfolio. It helps enable free head movement and a comfortable testing experience for participants. And finally, you get quality data with metrics you can trust, great precision and accuracy, and a good history in this field with over 10,000 published articles citing our products and more every day. And we hope that you join us. Finally, we'll dedicate the rest of the time for an interactive Q&A panel with my good colleague, Kirill Novikov, who's a research scientist on our team in Sweden. Throughout this entire session, I think you've already figured out how to use the Q&A function, but please continue to put your questions in there as they relate to eye tracking, Tobii Pro Lab, or your own research questions, and we'll address them during the Q&A portion. So before we start, I want to explain the task we're showing today. This is the Flanker task. This is a response inhibition task that measures the ability of a participant to suppress a response. The target stimulus is in the center. You can see it indicated here on the screen, and is either a left or right facing arrow. The target is then flanked by non-target stimuli that either correspond to the same direction, which are congruent, or opposite, and they're incongruent. The participant has a short time to identify the target before a fixation cross appears, and then the participant must look at the subsequent dot that's either on the left or right of the screen, matching the target direction. Usually the choice reaction time is analyzed, and since we've set this up in Tobii Pro Lab, we can also look at other metrics like latency to fixate or saccadic reaction time. So again, I hope everyone could hear me now, and now that we understand the task and what we're going over today, we're going to get started in Tobii Pro Lab. This is Tobii Pro Lab. Tobii Pro Lab software works with all of our hardware using different project types. So we have one software to rule them all. For a screen-based project, you would use this with our screen-based eye trackers, Tobii Pro Spectrum and Tobii Pro Fusion, as well as any of our older systems. For this project type, stimuli are presented on a computer monitor. For the Glasses project type, you would use this with the Glasses 2 or Glasses 3 hardware to analyze recordings. For the Scene Camera project type, you would use this with non-standard configuration, with real-world stimuli or with a larger monitor. You would need a scene camera to record the scene if you're using real objects. And finally, for our external presenter project type, you would use this when using ePrime 3.0 as the stimulus presentation tool. If you're using ePrime 3.0, Tobii Pro Lab can co-acquire the stimuli and record eye tracking data for easy analysis with our full complement of tools. To use Tobii Pro Lab, you would use a license key, which can be activated or deactivated and potentially shared across different PCs. While Tobii Pro Lab can be downloaded on any computer, you can only use one instantiation at a time per license that you own. Let's open our project. This is the project overview page. These are all the recordings that you'll see here on the main page. At the top, you see the different elements that we'll go over today: design, record, and analyze. For all the existing recordings, you'll see the duration of the recording, the date and time that it was recorded, and even the percentage of gaze samples found. If you click on Participant Variables, You can see participant variables that are already created, as well as create any new ones. In Tobii Pro Lab, you can create and code custom events, for instance, a verbal response to a stimulus. You can also add elements of each stimulus. In this case, for the flanker task, we want to know if the stimulus is congruent or incongruent. This will be useful later in the metrics visualization section. Here in the Design tab, we can see more about the project design. This is our timeline. We can create as many timelines as we want as well. In this timeline, we can see first is the eye tracker calibration card. Here's where you can adjust different features of the calibration. You can have 2, 5, or 9 points. They can be timed or manual by the experimenter pressing on a key to move forward. You can also use the point, a video, or even the resizing video, which is helpful if you are studying infants. To add elements to the timeline, you can either click on this button to add or drag and drop your stimuli in. In this timeline, we start with the instruction, which is using the text feature. You can type directly on this stimulus the instructions to your participants. Then we have these groups. We can see the stimuli that are in the group. For a particular stimulus, you can advance on time, key press, mouse click, or by gaze. In this case, we have it set to advance on time after 100 milliseconds. In the group element itself, you can decide the presentation order. In this case, we want all of these stimuli to be shown in a sequential order, but you can shuffle it as well, or even sample from a larger set. This is where you can set the congruency. This particular stimulus is congruent, so we can create that stimulus variable here. In the Record tab is where you'll conduct the calibration and start the recording. We've already had some recordings added to this project, so we'll move on to talk more about analysis. When you click on the Analyze drop-down tab, you see lots of different options, including being able to click directly on a recording. Let's do that. So now we're in the Analyze tab, and the first thing we're going to do is conduct a visual inspection of the data. In order to do that, I've selected one of the recordings. The first thing we'll do is play the recording. You can also change the speed to slower or faster. This particular task is called the flanker task. It's a response inhibition task that measures the ability of the participant to suppress a certain response. So you'll see what flashes very quickly is the target stimulus, flanked by non-target stimuli. They're either congruent to the target or incongruent, facing the opposite direction. This task was first published in 1974 by Erikson and Erikson. Performance can be affected by things like intoxication or neurological or psychiatric conditions. The goal of this task is look toward the target spot on either the left or the right after the fixation cross. I'll slow the recording down. So in this case, they should look right. For this particular replay, the Tobii IVT fixation filter was selected, but you can also replay using the raw filter or create your own custom filters as you wish. This data was collected with a Tobii Pro Spectrum running in 1200 Hz, so there's a lot of data collected every second. From here, we can look at some of the charts. First, you'll see the gaze data chart. This displays gaze points in X and Y coordinates. If we clicked on pupil diameter, You can visualize all of the pupil diameter estimates for each sample throughout the entire study. This data is in millimeters. You can even time zoom here to see a closer detailed inspection. All of this data can also be exported in the data export. This is just the visualization of everything that you would see in the data export. Next, you can see the eye openness. This is a relatively new data type. Eye openness is measuring the diameter of the largest sphere that can be fitted between the upper and lower eyelid. All of this is in millimeters from 0 to 14. So here you can see the eye openness signal as it changes over time. These are likely blinks. The eye openness is not dependent on pupil detection. It's a separate algorithm from gaze detection even if eye tracking is lost. So it's a really good benefit as you can assure that lost data is only due to blinks. This eye openness data can also supplement your inspection workflow, distinguishing between system noise and real eye movements. Eye openness itself can also be used by a variety of fields for measuring things like drowsiness or alertness. These features have a lot of potential moving forward, and we've identified areas for future development. Currently, the eye openness signal is compatible with our Tobii Pro Spectrum data, as was collected in this project, with plans to expand to other hardware in the future. In the project overview, I mentioned that you can create custom events. You can do so here as well. You can see events that have been created throughout the course of the recording, including sync events, if you were synchronizing your eye tracking data with some external physiological data like EEG. But you can also create custom events here. Now we're going to look at the visualizations. So the first thing we'll see is heat map. Heat maps are aggregated information over recordings. You can see here that the redder the image gets, the more people look there. You can change the opacity if you want to see through, or change the size of the radius if you'd like. You can even change from count to duration. The next element is the gaze plot. Gaze plots show individual recordings with the order of fixations. So you can see here, these are numbered, and they're also different colors for each of the participants. If you wanted to look at one participant by themselves, you can deselect. Within the visualizations, you can also create custom times of interest, which will allow you to look at specific slices of an entire recording. You can name it, create start and end points. You can see all of the media times of interest are already here automatically, but if you wanted to create a time that encompassed maybe multiple times of interest or a smaller segment of an existing time of interest, like the first second of the stimulus presentation, you could do so. With custom times of interest, you can export that total time as well as conduct more thorough analyses of that segment of the recording. Next, we'll look at the area of interest tool. Okay, in our area of interest tool, you can draw circles, squares, or irregular polygons. In this case, we've already added areas of interest. This is a left congruent stimuli. And then for the response, it would look something like this. This was the target, and we drew an AOI around the target. We can give it names. We can even link similar AOI across media. For example, if you wanted to link all the distractor stimuli together and compare to a target stimulus, you could do so. Next, we're going to review our metrics visualizations. The metrics visualization features give you a quick overview of results and trends. So here on the left, you can see all the different metrics that you can visualize. Here we have the time to first fixation for the stimulus variable, congruent versus incongruent. If this is a metric that you want to visualize, you can pin it to the sidebar. You can see that between the two groups, the latency to the target doesn't seem to be different. Let's look at the total duration of fixations. You can see here that for the total duration of fixations, which is essentially the cumulative looking time, the congruent trials had longer fixations than the incongruent trials. We can also look by participant variable. In this case, the female group tended to have longer duration of fixations than the male group. We can also look at total duration of fixations in a binned format. This chart segments the data by 500 millisecond chunks. You can change that here. Or if you want it to be smaller, here's what it looks like binned every 100 milliseconds. Okay, here we can see the binned data by stimulus variable between congruent and incongruent with 100 millisecond bins. This is helpful to visualize how your data changes over time. If we want to be able to look at this data later, you can click this pin button and it will pin to the top for easy finding later on. You can also visualize other things like pupil diameter or eye openness, also either binned or unbinned. There are lots of other metrics that you can visualize as well based on your particular research question and needs. Next, let's move on to the quantitative results with the metric selection and export. For the metric selection, you should also decide if you want to have filtered data or raw data. We have a preset gaze filter that we call our IVT filter or velocity threshold. You can see the different options related to this filter here. You can use the raw data or create your own custom IVT filter if you wish. It's important to decide beforehand which metrics are most important to you in your research question. You can find guidance on this through expert papers or articles from your field. Researchers commonly use fixation metrics like fixation duration and latency to fixate. They also use count, whether it's fixation count or visit count. You'll see event metrics like number of events, interval duration between events, mouse clicks in an AOI, as well as latency and count. You can see click metrics, and you can even see saccade metrics like amplitude, velocity, or count. You can find the average fixation pupil diameter and the average eye openness across a stimulus interval as well. We even have specialty reading metrics, counting regressions, and rereading durations. There are a few different formats depending on what you need as well. The metrics export is the last step from Tobii Pro Lab before the data is exported to then be imported into your favorite analysis software. But the final thing that I'll show you is the data export. The data export is where you'll find all of the XY data from each eye and each sample for the entire recording. This is where you'll also find the pupil diameter and eye openness estimates for left and right eyes for analysis in your favorite analytic software. To export, click here. And that is it. that's how simple it is to get started with Tobii Pro Lab to design and analyze your screen-based eye tracking data. So moving on, we envision Tobii Pro Lab as a productivity software. There's a job to be done, and here are some tools to help you make this happen. So we hope that this easy-to-use software helps solve your research problems. There's always a time investment when you're getting accustomed to using any new software, but with this platform, we think that there's a quick ramp up from learning how to use it to actually moving your research forward. So if everybody can see the screen, we have some helpful links here. You can scan this QR code for more information, including how to download a free trial version of Tobii Pro Lab. You can also contact us and learn how to access our free funding support services, which will help you in editing and preparing grant proposals to get money to buy eye trackers from us, and where you can find other webinars like this on our Learning Hub. As I mentioned, for anybody who had any issues with the webinar today, you will get a link after today with the full webinar, and you can also find other webinars on our Webinar Hub, as I mentioned. If you are an existing customer and want to get connected to our customer care team, please visit our new site at connect.tobii.com. It used to be Tobii Pro, now we've condensed and moved to tobii.com, so existing customers or even prospective new customers who want to learn a little bit more. But if you want to talk directly to customer care, it's connect.tobii.com. And if you're not yet a customer, but would like pricing or to discuss with any of our great colleagues how you can use eye tracking to answer your research questions, you can find us at tobii.com/contact. tobii.com/contact. Before we get started with your questions, and keep putting those questions in the Q&A section, especially about what you saw, or if you have questions about your particular research question and how to incorporate eye tracking, we're happy to answer those today. But before we get started, I have a couple of poll questions that I want to ask. The first one is asking, have you used eye tracking for research before? So you can click directly on the screen and let us know if you're using eye tracking currently, if you've used it in the past but you're no longer using it, and then please answer if you haven't used eye tracking at all yet. We're curious about the knowledge base of the people who join these webinars with us. Looks like we have quite a number of people who are using it currently. Just going to give it a couple more seconds, so if you can make your answers, I'd love to share with everybody. I think it's interesting to get this feedback from you all. Thank you so much. Okay, I'm going to close this now and share the results. So 55% of people said they're using eye tracking currently. I hope you're using Tobii systems. If not, maybe you'd consider them for your next purchase. Some of you have used it in the past, and there's about 31% who've not used eye tracking yet. So welcome to all of you. I hope you all learned something interesting today, or at least gotten some places to start to ask some questions. I see lots of great questions coming in. One more quick question for you before we move on. Moving forward, what would you like to learn more about? Would you like to learn more about how you can use Tobii Pro Lab for stimulus presentation and design, or some of the other options for stimulus presentation? Do you have questions about calibration and recording, or questions about data analysis? Pretty big buckets, but we're curious what you might be interested in learning a little bit more about. We don't have a select all option here, I don't think. But maybe some people want to learn about everything. So just a few more seconds. Okay, all right, let's share those results. So 13% want to know a little bit more about the front end, stimulus presentation design, 27% is calibration, and about 60% data analysis. That tracks with what we hear from customers, and especially when we've done other webinars like this before. So thank you so much for your feedback. This is really important for us to take in as we're planning for the future and designing more webinar content like this. So thank you so much. Okay, so now I'm going to welcome my good colleague, Kirill Novikov, who's a fellow research scientist. And let me hide this. Sorry about that. And let's get to your questions. Hi, Kirill. Thank you so much for joining us today.
Hello, thank you.
Yeah, so first question, what is the use of the percentage of gaze samples found that I highlighted on the overview tab?
So yes, so this is basically the percentage of gaze samples, or in fact, so when eye tracker is, so before it measures, before it does the computations of the gaze data, it kind of needs to do certain things on the eye images. So I would say that this is the percentage of successfully taken and identified, well, eye features, and the feature that we need to know about in order to be able to compute the gaze data. So yeah, pretty much it. Of course, it can never be 100% because, you know, we blink, we can turn around. But if you see that this value is too low, for example, then you should probably just inspect the data, and there might be some reasonable explanation for it, right? Like the participant was constantly moving away or so. So yes, and also we would highly recommend, well, depending on the type of your study, if you know that your participants will be more likely to look away from the screen, so you can also add a participant camera in Tobii Pro Lab, and then you can kind of have this video together with your eye tracking data. I hope it answers the question.
Awesome. Yeah, that's great that you mentioned the web camera. I did not go over that today, but we do have options in Pro Lab when you're recording to both collect the participant camera and audio. So if you're interested in having an extra check of where the participant's head's oriented, you know, are they still in front of the screen? And then if there's any kind of audio feedback that you want to hear, you can get both of those, and they're time locked with the recording and replay in Pro Lab. Awesome. Let's go to the next question. During the walkthrough, you mentioned sync events. How can I synchronize my eye tracking data with other devices? This is a great question. Kirill, you want to explain about our sync out?
Yeah, sure. So during the design process in Tobii Pro Lab, you can send events at the onset time of your stimulus. So this works for videos, for example, pictures, or text elements even. So in order to do so, your computer needs to have a parallel port. Alternatively, we support certain USB to TTL converters, and this is the best way to do it. And this is especially important if you have, if you want to synchronize it with EEG, which is dependent on the experiment that you are doing, high demands on timing, right? Certain devices, certain solutions could be integrated with Pro Lab already, like for example, Shimmer GSR. You can run well together with your eye tracker in the same project. But yeah, if you want to synchronize it, this is the best approach. Or when talking about Tobii Pro Spectrum, it is possible to send TTL events to the eye tracker itself. So yeah, it only works for Spectrum though, or glasses, yeah, glasses 2, glasses 3.
Awesome. Yeah, if other people have questions about synchronizing eye tracking with other devices, other physiological devices, please reach out to us, because we have some partners that we work with that actually have combined data streams. So we can combine the Pro Lab data stream with, for example, the Brain Vision Analyzer software. So Analyzer can import the XY coordinates from Pro Lab. So it makes it a really nice combined data solution. So if you have questions about compatibility, please reach out and we'll be happy to discuss with you.
Yep, sure. That is true.
Okay, Ravi had a question, actually a couple different questions that seem to be within the same bucket. Is this process the same with the Tobii device and the HTC Vive Pro Eye headset? And then how do you use Pro Lab with Unity?
Yeah, the process is exactly the same. The thing is that you cannot really use Pro Lab with Unity. We have a possibility to create experiments for VR360, so which supports videos and pictures. The process is exactly the same. So you just add these pictures and videos to the timeline and do it with the areas of interest in exactly the same way. So the only thing is that it is supported. So you need to have a version 1.162 or earlier, so in order to kind of run your VR360 experiments. When it comes to Unity, you will have to use our SDK solutions, so it cannot really be done in Pro Lab.
Yes, our SDK is available on our website for download. Or if you have more questions, again, let us know. I don't want the answer to be if you have more questions, let us know every time, but please feel free to reach out. Okay, got some other good questions coming in here, so keep your questions coming. So Lauren asks, we are about to start methods development using our eye tracker. What would you consider to be the most robust paradigms for observing pupillometry or eye gaze effects so we can try replicating them in our lab? Do you have any feedback on that?
Paradigms. Well, it's a very good question. However, I don't really have a ready answer to it. You can obviously record your pupil data with all our eye trackers, both wearable and screen-based. You can even like visualize this. We even have like some filter settings you can apply on your pupil diameter data. The thing is that we do not do any calculations on pupil diameter automatically. And if you want to kind of work with your pupil data, of course, there are certain considerations, right? Like you need to be very, you need to have a very good control over your light conditions, overall ambient light, even like the brightness of your stimuli and stuff like this. But I would suggest having a look at our portal, so connect.tobii.com, where you could find certain articles related to it, in fact, which also have certain references to publications. So I think this is the way I would kind of go for. So just, yeah, probably some literature review related to it. I don't know, Marissa, if you have any comments on this.
I was trying to think of something because I feel like we have a demo project. Don't we have a demo project that maybe I'm thinking of something else? Let me think about it a little bit, Lauren, and if I find something, I'll send you an email. I can check around too. So yeah, feel free to use the Connect portal to see, but I will ask and see if I can find a paper for you or something, because I think that would be good.
Good point. We can get back to you with this. Definitely, we have certain links related to pupil diameter, including, I assume we even had a webinar on it, in fact.
Yeah, I can find that webinar too and send it to you, Lauren. Lauren's second part of the question is tips and tricks for calibration.
Calibration, well, it depends on who you want to calibrate. So generally speaking, of course, the more calibration targets you have, the better the performance is. You need to maintain the optimal distance, or at least let your participant be around the optimal position. Yes. Oh, I actually see the answer is healthy young adults. Thank you for the clarification. Yeah, well, then they're pretty general. So I would say 5 calibration targets in most cases is good enough. If you want to do a reading study, though, maybe it's a good idea to have 9. Well, or in certain scenarios. Other than that, just standard settings. Yeah, of course, if you can, always try to validate your calibration. So we have this option as a setting for your calibration element. So just extra validation dots, and if you validate, you can get well, more, I would say, fair results, because this is basically well, the validated data, right? So in different locations.
Yeah. Lauren, I think you have a fusion, if I'm remembering correctly. So and especially if you're working with, yes, okay, great. I think if you're working with healthy young adults, I would assume that you would get great calibration. So if there's light level does matter, I think to a certain extent, if the room is very dark versus being sort of natural light, right, Carol? So we kind of recommend like a
300 lux, yeah, it's the optimal, of course, but yeah, I assume that you don't really work in like very extreme conditions. However, it will calibrate even in the full darkness, because eye tracking is based on infrared light, and we have illuminator that will illuminate the participant's eyes like in any conditions. Yeah, the optimal is indeed like standard room light. That is.
Yeah. So yeah, let's reconnect later on, and I can introduce you to your new account manager as well, to hopefully try to get some of these questions answered for you. So I hope that helps. Thank you.
I
Cool.
have a question, like if I may, Marissa. So there is a question that is also related to calibration that I can see, which was if it's possible to recalibrate during an experiment. So when you are already like collecting the data, it is not possible to recalibrate. However, we don't really see any needs in this, considering that our eye trackers are very tolerant for the head movement, and we use 3D eye model, in fact. So which means that no matter where in the track box the participant is, the eye tracking will resume, even when they like completely walk away and then come back. So you don't even need to recalibrate. However, if for some reason you feel like it's needed, the only way to do it is to start a new recording. And then you can also reuse like old calibration results with the same participants. So this is possible to do.
Yeah. Awesome. Great questions, everybody. Here's another couple that are related to screen-based. How do you set times of interest? I'm guessing that we're asking about custom times of interest because there are lots of different times of interest, but Kirill, if you want to kind of give the overview a little bit more detail.
Of course, sure. So yeah, as Marissa pointed out, or at least I develop her ideas. So certain times of interest will be created automatically, so you don't really need to do anything. But if you want to create custom times of interest, you need to define the start and the end point of it. And for this purpose, we have different types of events that we already mentioned during the webinar, right? So we have events that you can log yourself, for example, you can be as accurate as 1 millisecond. Certain events are logged automatically, like participant event, each key press, mouse click, of start and stop of each stimulus. Certain events can be imported. For example, if you go for an external presenter, events. So pretty much all the events that you can find there could be used to create times of interest. I hope it answers your question.
Yeah, lots of flexible options for times of interest. So I think that's great. Martina has a question. Is there a way to export screen recordings from Tobii Pro Lab in an automated way? So I'm not sure if you mean the data or like the actual like sections of the video, but maybe let's talk about how you can combine data across different screen recordings in Pro Lab.
So yeah, you can, for example, if the purpose is to kind of distribute the data collection, or on the contrary, if you have more than one analyst that is who's working on your project, you can select like a part of your project, so you can basically select which recordings you want to export when it comes to the project itself, and also in the data exports and also in the metrics, you can choose which recordings you need to export. So by just selecting or checking the respective boxes. So this works both for metrics and for data export. And also, as I mentioned, you can export, you can choose which recordings you want or you need to export for distributed data collection or distributed analysis.
Yeah, and if you're asking more about combining the data across different screen recordings, you could utilize the custom times of interest because you can set the event markers to start and stop the custom times of interest across different screen recordings, even if they're not seeing all the same thing. You can also draw AOIs that are tagged the same. So if you have, let's say, a target on recording 1, even if it's again a screen recording that's not the same as screen recording 2, you can group those AOI across different recordings, and that might be another way to sort of work across multiple screen recordings. It's a little bit trickier of a process using screen recording, but it does open up a lot of different types of data collection. So I hope that helps, Martina. If you have more questions about that, you can feel free to go to Connect portal. You can, if you're existing, sounds like you're an existing customer, so you can talk to our customer care team, or you can always send me an email. I put my email in the questions, so, and I can make sure to get it to the right person. Okay, another couple questions from Ravi. Is single point calibration possible? Is it possible to calibrate each eye? I can take this in Pro Lab for screen-based recordings. We have the options for 2 calibration points, 5 calibration points, or 9 calibration points. Those are the only preset options we have in lab. But for monocular calibration, I don't think it would be calibrating each eye individually, but if you wanted to use a monocular calibration, you can. I think with the spectrum and I think with fusion, is that right, Kirill, or is it just spectrum?
Yeah, fusion as well.
Okay.
That is correct.
Yeah, so you can use fusion and spectrum if you wanted to just calibrate one eye. I hope that helps. Let me see. We're coming to the end of our time here. Let me see if there's any other questions that I missed, or this is your last chance if you had other questions to put them in the chat box. Like I said, we will send out this recording after today. Since you registered, we'll send it right to your email. Feel free to share it. It will be also public on our Tobii Resource Center. Oh, grouping function. Thank you, Krista. Sorry about that. So a quick question about the grouping function. How does that work when preparing the timeline?
So the grouping function and the timeline. So it's typically used for, I don't know, like counterbalancing purposes, for example, or randomization. We actually have, I think we should have it, if I'm not mistaken, yeah, even an e-learning module that basically explains these kind of features. If it's not out yet, then yeah, like please forgive me, it will be soon. So I know that at least like well, we've been working on it within the team. So here or there you will see some examples on like what it's used for. But yeah, it will help you with randomization with like certain ordering features because you can apply yeah these kind of actions on it. Like certain samples can be taken, or for example, if you need to present the same picture before you set or your pool of stimuli, like a fixation cross, that you want to kind of, instead of copying and pasting it across the timeline, you could kind of put it separately and then create a loop that will be repeating like a sample taken from your stimuli pool and this fixation cross and so on. So yeah, it's used for.
Yeah, lots of great options with the group function, looping, sampling, keeping things randomized or not as well if you want to keep things presented in the exact same order. And I think in this particular project, she utilized it in several different ways. So both for keeping things in order within a group and then in repeating. So it was lots of repetition and looping in this one. So great question. Okay. I think we will be wrapping up. Thank you so much again, everyone, for joining. Thank you, Kirill, for joining me today. Great questions, great engagement, and thank you all for your patience. This, as I mentioned many times, this will be sent by email. Please feel free to share, get in touch with us, download Tobii Pro Lab for yourself. Reach out if you need anything. We're always happy to help. Thank you so much.
Thank you. Bye.